you have to account for extraneous variables. These are variables that can confound the study or get in its way and basically mess up your findings so that you can't say X causes Y. So let's say the Bandura study, what might be some extraneous variables that you would need to account for? It's kind of tough. Let's say, okay, first of all, in sampling, like if you don't sample correctly, that can be an extraneous variable. So let's say you have the boys watch the aggression and the girls watch that's not even sampling, that's assignment. If you assign it that way, that's going to be extraneous, it's going to confound the study. If you have, let's say you had the ones who watched the aggressive video, let's say they are all doing the study late at night when they're already cranky. Okay, that's going to confound the study, that's an extraneous variable. So you need to make sure the conditions are exactly the same for both. Is that clear? Yeah. All right. Let's see. Okay, operational definition. So again, we talked about that, how many times a child is defined as aggressive if he or she hits the Bobo doll with an object other than his or her fist 5 times within 5 minutes. Okay? It's very clear. Confounding variable when it messes up. Okay, sampling. So random sampling, so there's a sample and there's a population. Is the population the whole population of the United States? What is the population?
Majority.
The population is the group of people that you're intending to measure, like that you're intending to apply your findings to. So let's say I want to know how often the average Birmingham student studies. My population would be what? Birmingham. Am I going to sample all of Birmingham? No. No, I'm going to choose a sample, right? And the sample has to be random. What does that mean? So everybody has a fair chance of being chosen. Pulling out of a hat would be perfect. So pulling names out of a hat, if you put all the names of Birmingham in a hat, okay, it could be a very big hat, and then pull the names, pull out 20 names, that would be your sample. So let's say you only choose 20 people. What's the problem with that? It's too little. Not a representative, small sample size is bad. We proved that with M&Ms, right? Or at least we tried to prove it. Okay, and then let's say I only choose my AP Psych class.
Well, we're gonna
So that's called a convenient sample because it's convenient. You're right here. You're an AP Psych class. It's not representative of the whole school, right? The whole school is not taking AP classes. Okay, only a small percentage, or pretty small percentage. Okay, or even worse, what if I only sample you guys who came on a Saturday? Okay, not a representative sample. Okay, all right. I know some of the students couldn't come. I know, so definitely not their fault. Okay, so sampling bias. So when you don't account for those, like when you choose a small sample size or you convenient sample, just like I said, like you sample who's near you, you end up with sampling bias, and that can confound your study. Okay, at the mall. Let's say they want to find out, let me see. Let's say they, trying to think, those kiosks. Okay, let's say they're doing some kind of study or survey, and you know those kiosks at the mall where they sell little things, okay, like Dead Sea mineral lotion and stuff like that? Okay, so what if they only sample the people that go up and talk to those people, okay? You're not going to, and they ask them, what they think about the Dead Sea mineral stuff. You're not going to get a representative sample because those people going up are already interested, all right? So that's what I mean, like you need to have a representative sample. They need to represent the whole population that you're trying to study. I don't know if that was the greatest example. So once you have your sample, once you have your sample, you need to assign them. They have to be randomly assigned into what 2 groups? Control and experimental. This is where you do what?
flip a coin.
Flip a coin. Okay? So let's say you guys are my sample, and I come up with Edwin, flip a coin, heads. Okay, he's in the experimental group. Chris, flip a coin, tails. Okay, he's in the control group. Okay? Alright. So that way each subject has an equal chance of being in the control and the experimental group. Okay? Placebo effect we talked about. We're good on the placebo effect? Okay.
Yeah.
And usually the placebo is just like a sugar pill. It's like a pill that does nothing, basically. Okay, advantages of experimentation. Huge, huge, huge advantage. You could draw cause and effect conclusions. You cannot do it with correlation, again. Disadvantages. What were the disadvantages? Ethics. So sometimes you can't conduct a study because it's just unethical. Like, for example, you want to see malnutrition in infants. Well, you're not going to starve infants. It's not ethical, you know? So in that case, you do a correlational study, and you look at infants, you know, maybe from who happen to be malnourished, and then compare them with infants who are properly nourished, and then you measure IQ. Okay? Or it might not be practical, right? It might just not be something you're really able to do, like move people physically to different locations for their whole lives. Or another thing is they tend to be artificial. They're kind of in fake settings. So you might not always be able to generalize that to reality. Okay, so for example, like the Milgram study, you know, no matter what, it's still a study. You know, it's still not real life. So can you generalize that to reality where people actually follow orders that easily? We're not really sure. Okay? All right. Is that clear? Studies can be longitudinal or they can be cross-sectional. Longitudinal, what's the key word in there? Long, over a long period of time. Cross-sectional, snapshot. Okay, like just right now we're going to measure you guys. Naturalistic observation. So this is where you're sitting on a park bench and you're just people watching and writing what you see. Okay, what's the benefit of it?
It's real.
It's real, right? Opposite of experiment, it's not artificial, assuming they don't know, like see you. It's done a lot with animals, Jane Goodall, all that stuff. Okay. Again, can you infer cause and effect? No. You can only infer cause and effect from experiments. Okay. Case study. This is an in-depth report on one person. Okay. So students with IEPs, which you know we have a lot of students with IEPs on our campus. It stands for Individualized Education Plan. They'll do a case study on them where they'll look at, you know, their history of behavior and academic success from the time they were like in elementary school to now. They'll give them maybe some psychological tests, maybe some learning tests to see if they have a learning disability. They'll interview them. They'll do a whole battery of tests so that they can figure out how to help that student. That's called a case study, okay? And it's not just for students. It's, you know, if somebody goes and complains of some like let's say, you know, they're experiencing, you know, mental disturbances like hallucinations or something like that, they might do a whole history of them, case study. Okay? The benefit of that is it's very in-depth, but can you apply that finding to the population? No, because it's one person. Okay, so that's the drawback. Surveys, what's the disadvantage? People lie, deceptions, and self-report, right? You guys, even though you all said you'd eat bugs, you basically did. So once again, you didn't prove it to be true. But people generally lie on surveys. They want to look better. They care about what others think. There's another issue with surveys where if somebody only, like, let's say someone takes a survey and they're just doing it to get it over with quickly, or maybe they're being promised money, and they just go, yes, 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 yes. Or they do some kind of pattern like, yes, no, yes, no, yes, no.
It just okay.
What is that called? Where they don't look at the question, they're just, you know, writing, yes, you know, they have like a pattern of answers, or they're just, response set, good job, Max. Response set, okay? Response set, okay? So, yes, no, yes, 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 yes. Raise your hand if you've done this before. I've done it before. I've started surveys and with the best of intentions, and then it gets to the point where it's like, when is this thing gonna end? And then it's like, yes, 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 or no, 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 no. Okay? It happens, and that skews the results of the survey. Okay? Alrighty. Is it still recording, Elizabeth?
Yeah.
Okay. Man, that iPad. I guess it has a lot of gigs. Who knew? Okay. So, data, numbers, yay, get excited. Remember, if you think you can't, it's going to impact your performance. You got to think that you can. So, mean, median, and mode. Which finds the average?
Mean.
The mean. It's mean because it's a lot of work, right? Median is?
The middle.
The middle. Small, medium, large. Medium is in the middle. What do you have to do to the numbers first? Put them in order. And what's the mode?
How many it comes up?
Most. Momo. Right? Okay. So the median, again, put them in order, find the middle number. What if you have an even set of numbers? Let's say there are 4 numbers, and it's like 1, 2, 4, and 5.
Add 2 and 4 divided by 2.
Yeah, so you take the 2 numbers that are in the middle, and you find the average of those. Okay? So again, let's say you have 4 numbers, a data set of 4 numbers, and you're asked to find the median. Well, there's no middle number, so you take the 2 middle numbers, and you find the average. 2 plus 4 divided by how many there are, which is 2. And what do you get?
3.
You get 3. Okay?
I thought there was a 4 and a 4, and I did 3 instead of 6.
It's obvious that it's 3, but let's say it's you're finding the average. Let's say it's more like this. Let's say it's 1, 8, 14, and 5.
11.
Or not 5, shoot, I have to put them in order, right?
11.
18. Okay, so yeah, so 8 plus 4 divided by 2, it ends up being 11. Okay, 22 divided by 2. Okay, so you take the middle 2 and you find the average. Clear?
So it's just like
Okay.
Okay, so you find the mean
Of the 2 in the middle. Yeah. Okay. Correlation means there's a link between 2 variables. Remember the thumbs?
Yeah.
Okay, so we're going to tell if it's positive or negative. Remember, positive, they point the same way. Whether it's like this or like this, they're still pointing the same way, so it's positive. If you get one of these or one of these, it's negative. So, here we go. Alcohol consumption and liver damage. Positive, right? More alcohol, more liver damage, right? Darian today lives in a world of crime and craziness. Okay, what about, let's say, exercise and body weight? More exercise, tend to have lower body weight? Negative, right? What about amount of donuts consumed and blood pressure? Positive donuts, that really affects your blood pressure, but yeah, probably positive. What about amount of cigarettes smoked and overall health? Negative, right? So more cigarettes, a decrease in health, right? What about amount of hours studying for the AP Psych final and your grade on the final? Positive. We don't, right? Okay. Okay, so we get that.